This is a talk on this library that we wrote at Foam. Does anybody know, people here are like more, what are you, like Haskell developers or Purescript developers or Ethereum developers? Is anybody here actually an Ethereum developer? Okay, you are. So, and then who writes Purescript? Okay, a few people. And then who writes Haskell? The rest of you, presumably. Anyway, so this is kind of like in the middle of Purescript and Ethereum as a talk. It's not assuming that you really know a ton about either one. So I figured there's probably going to be more questions about the Ethereum stuff than anything else. So that part's fairly interactive. If you want to ask questions that seem relevant or important during it, you should, because if you haven't looked at it before, it's kind of like a pretty deep rabbit hole of stuff. So the plan of the talk is to talk a little bit about Ethereum and then do some basic coverage of Purescript as a language for people who haven't written in it. And then we'll talk about this Purescript-web3 library. And I am going to start by showing at least a little bit about Ethereum, and then I'll give you an example. We wrote a couple of demo apps. One is like a really simple hello world type thing. One is like, I don't know if you've heard of CryptoKitties. They're like really expensive Digimon kind of that you can buy on Ethereum right now. They're really expensive. Anyway, we thought it was funny, so maybe I'll just start by showing you that. This is the CryptoKitty. I don't know, there's some Ethereum smart contract somewhere that regulates the sale of these things. This one is up for sale, or at least was earlier. Anyway, you're basically just buying this digital image, and they can procreate, so they have like some genome, and then they have parents and stuff. And anyway, like, looks like, I'm gonna start this in the background. This is our like CryptoKitty monitor, which I made in like an hour earlier. So hopefully it's some demonstration of what you can do with this stuff. We'll check on it later, because I don't know, the images, we're getting trouble from like Google like has some sort of S3 bucket where these SVGs are, and because I guess people are hitting it so often, they're kind of like regulating our app. So our images aren't coming through, but the transactions do. So Ethereum is a crypto, it's mostly famous as like a kind of, younger Bitcoin is kind of how a lot of people know it, but it's a lot more complicated than that. It's the second most, in terms of market cap, valuable cryptocurrency. It's the most popular blockchain of its class, which is not just a shared ledger of account balances, but it's a full-fledged computing platform. It has a Turing complete state machine known as the Ethereum virtual machine. People write what's called a Solidity is like the most popular programming language that targets this virtual machine. It has a reputation for being really complicated to do well, and there's a lot of problems with it that a lot of people complain about it. Yeah, sorry. Oh,
if you could get the CryptoKitties to like pounce on it,
I just got to quit this altogether. Yeah, later. Okay, so wait, what happened? Okay, there we go. So anyway, this is a graph of Ethereum transaction charts over time since it's launched sometime in 2014, I guess. Basically what you're seeing is that it's become extremely popular recently. It's also kind of made headlines because the price has gone up significantly. More interesting chart would probably be this one, which is the unique Ethereum address growth chart. So this is the number of this is the transaction growth per unique Ethereum address. So it's not just a few people using it really often. It's a lot of new people using it, and the growth is sort of exponential. This is as of, I guess, a few days ago. So it's not going away. It's pretty big. How popular it will be in the future is kind of determined right now based on the applications that are built on top of it. Here's a graph of its market capitalization. Earlier this year was when things got pretty insane. So it saw a jump from around $10 per Ether value to something in the 300s in like a month or 2-month period, followed by a few, sort of small dips. But now I think the price is something around $460 per Ether as of today. So it's pretty interesting from an economical point of view, but we're here from the program point of view. I mentioned earlier this language called Solidity. It has a JavaScript-like syntax. We'll see some examples of it later. It has some special blockchain cryptography and signature recovery primitives that are subsidized in some sense by the network. It has, basically its type system, it has a relatively simple type system of sort of sized arrays of basic primitive types like sized and sort of Boolean values or dynamic types like strings. And one interesting thing about Solidity, I'm not sure if it's true of other languages that target the EVM, like there aren't really any others that are widely used, but the build artifact of Solidity smart contract is something called an ABI. It stands for an application binary interface. It's a JSON file that tells you basically how to interact with the smart contract. It tells you function signatures, return values, certain modifiers that function may know about, such as is it possible to use this function while sending ether to a contract, and other things called events, which are basically how you would interpret the Ethereum logs that are produced as a result of running transactions in this contract. So here's an example. It's a contract called Greedy Storage. Up at the top, you see this uint public M. This is a declaration that there is a global state of this contract, namely an unsigned integer of size 256 bits. This public keyword is basically just automatically generates an accessor function for this value M. Event. So an event declaration is basically your chance to talk to the outside world. Like the way that transaction cycle works in Ethereum is that you submit a transaction, which is basically like a chunk of bytecode that gets executed by a particular function in a particular smart contract, and you can't really wait for the result because the block time, at least in its current form, that's not how it's meant to be used. So block time is something like 30 seconds on average. So rather than like submitting this function, which simply, for example, takes another uinteger, forget about this description for a second, it adds it and then returns it. Because this does a state update, this is a transaction, which means you're going to have to wait until a block is published before you can really get the result. So the way that you consume the output of like state updates or transformations of smart contracts is through this event log system. So this declaration here, for example, is used to say an address is an Ethereum address. It's basically an actor in this world. You can see here in the function over. Yeah, go ahead.
How many blocks do you have to wait to consider a transaction to be confirmed?
Well, right now the answer would be something like it's probabilistic. So it would be statistically impossible, barring a hard fork of the network for some external reasons, that you would have to wait longer than 6 blocks or so to make a confidence. But that system it lacks what's called finality. So that means that you can see a block be confirmed, but then later in the future it might go back and be reverted. There's a series of what's called EIPs, or Ethereum improvement proposals. One of the big ones is a change in the consensus mechanism from proof of work to something called proof of stake, and that will institute some sort of finality so that you won't see that behavior anymore. Once you see it go through, you can say that it went through. Anyway, this override function, basically what you can see here is that it has some keyword payable, which basically indicates that this function can take some ether and deposit it to the contract, for example. So this override function requires that this person is sending at least 1,000 basic units of the Ethereum currency. It sets the value, and then then it tells the outside world that whoever sent that transaction just overrid that value. So this is a very simple, like, just to show you the syntax of what you're dealing with. And the kinds of things you can do with this language are pretty limited. And that's almost by design, because this is like the world's most expensive and slowest computer. But, and so like right now, you can imagine if you were offering the services that, say, a real virtual machine would have, like what that could open up for. At this point, you know, if you were to submit this override or increase transaction to this contract, it would be replicated across every computer in the world that's running an Ethereum client. And that's like a huge waste of energy to do relatively simple things. So the idea is to like keep the language simple and the target virtual machine simple for the moment, while maybe you solve the scaling problem and then come back later and do some additional work here. The function selector, basically, like I said, when you submit a Ethereum transaction, you basically just submit a block of byte string which somehow indicates what function you want to execute and how you're going to do it, with what arguments. So a selector, I use this word later just to cover it here. The other thing, it needs to be sort of deterministically computable without asking somebody what it is. So the way that they do a lot of this stuff in Ethereum is like they just take sort of like substrings of some hash of something. So for example, a selector for a function is by definition the first 4 bytes of the SHA-3, or actually I think it's, I don't know the difference between Ketchak 256 and SHA-3, but some hash that got approved as some standard. Anyway, these kinds of things are, yeah, so like everything in Ethereum is a hash, basically. So like the function selector is a hash, like addresses are hashes of keys, and like this is how the whole thing works. But anyway, in case you hear this word that I'm going to use a lot later, this is what it means. It's a way to uniquely identify a function. I was going to talk a little bit about type stuff because this is like a typed meetup. And so type safety on the chain is basically non-existent at the moment. There's a lot of work underway for strongly typed languages targeting the EVM. So Christopher knows some people who are working on something interesting at, what is that company called, DAppHub? Or, yeah, DAppHub has like a PL team who's working on this problem. There's some guy at the University of Illinois who wrote something called K-framework, which I only learned about when I started this project, but that's like a formal analysis tool used. It's language agnostic. It's basically like an interpreter, which you can, if you can specify the semantics of your language in this interpreter, you can run all kinds of like state analysis on like possible states of the program, and it's pretty heady. So he wrote something called KEVM, which is EVM semantics and K-framework, and that's being used now, hopefully, somewhere. Like type-safe EVM language wouldn't necessarily have prevented some of the infamous bugs. Maybe you've heard about some of these like bugs, or what I would call like catastrophic failures, where somebody writes some sort of multi-sig escrow type contract. Turns out there's some really elementary loophole, and some kid from who knows where is able to like black hole $300 million in Ether. And then, you know, it's like we move on the next day and the price is unaffected, and like the whole, it's like it never happened. So really the fundamental problem here is that like you're calling out from one Turing complete language, or at least the way that, one way to look at it is that you're calling out from one Turing complete language to another in which the types system is not preserved across the boundaries. So like you're, and the type system of the target is almost non-existent. So what you're looking at is like a lot of things to go badly between like, let's say, application code and you know, the byte code that's executed on the EVM. But even further than that is that you're kind of like, no matter how your application uses the smart contract code that you uploaded, you're not preventing anybody else from using that code in a completely unintended purpose. So you've basically exposed every inner working of how your smart contract works, and the only thing that can really save you at that point is whether or not you've done thorough security analysis. No application code that you wrote is going to be a security measure against somebody else's malicious intent because they have your source code. That's the whole point. Type safety off the chain, this is where you can do some work to prevent some catastrophic failures, and that's why we like this library and the sort of, you know, sibling library, HS-web3, which is the Haskell implementation that inspired this implementation. So things that you can prevent statically are things like encoding errors. You know, if you have a byte string, sorry, if you're expecting an array of byte strings of length 4, and let's say you're using like Web3.js or whatever, you give it 3. Don't even think that it might know. It might know. It might not. You'd have to read to find out. It's like the kind of the problem. Improper value transfer. So this is kind of a big one. Like it's mitigated by this payable keyword. This payable keyword means that if you're trying to send, for example, you notice that this increase value function here does not have a payable keyword. It means that if you submitted a transaction which tried to pay this contract ether to perform this operation, the transaction would fail. And that's like a feature, I would say, that you can't accidentally send ether to something that doesn't need it. However, it's not going to. There's like many different denominations of Ether. Like the lowest denomination, because this is another kind of funny thing, is that there are no floating points in the Ethereum virtual machine. So everything is an integer basically, and that means that to solve that problem, they just like tried to make a. Well, they have 256 bits for integers, so you can start with something really small, like 1 Wei, which is the name of a denomination. It's 10 to the minus 18 Ether. So there are many denominations that sit in between Wei and Ether, and the point is like, how do you specify the value of transfer that you're doing for something? 1 Ether will get you pretty far today on the mainnet, like way further than you probably have to go. So the point being that we can somehow also control at the type level the amount of value that you're going to deposit on a given transaction. Function argument mismatch. This is another one of those things that I don't know if Web3.js does or doesn't do. I know that it doesn't. I don't know. I don't even really care. But the point is that you should know statically like what you're doing, and you should get compile time errors for argument mismatch. Purescript goes even a little bit further and has this like it's difficult to write functions and sometimes that have type like int to int, int to int to string or something like this. And Purescript takes it a little bit further because of the records. The records kind of help with that, where you can like pass around records or even sometimes partially filled records in order to like mitigate that problem as well, pretty natively. Migrations in CDCI was kind of an unintended bonus that we got for free. We didn't really see that one coming, but because we do code generation based on the API JSON object that I was talking about. So basically, like every time that you run a build, you never like check in your built code that corresponds to your contracts. You keep those JSON objects somewhere in your repository or your build directory. And then every time that you're building a project or new, like you're cloning it new or whatever, you build those as part of like an NPM step, and that generates your client library that you're going to be using. And then that way, if your contracts changed and your functions were relying on old stuff, then they're going to break immediately. Whereas this is one thing I know that I don't know how they deal with it, but I know it would be a big problem in a language like JavaScript, where we were doing some experiments. We changed some contracts a little bit. We're pretty sure we changed the way they were being used everywhere, but let's just be hopeful that we wrote enough tests to cover it. Like this is one of the places where we can't really fail. Type safety is another bonus of it. This is something, I think everybody here more or less knows what Purescript or Haskell is, so it's kind of like a thing that I don't have to explain too much. But the conveniences of having a type-safe language to work in all the time, like otherwise what are you going to do? Use JavaScript basically, or somebody came up with some TypeScript bindings, and that means that even if you're a Haskell developer but some part of your code relies on front-end Ethereum stack, you're going to have to venture into that land, which maybe you don't know very well. Like in some ways, I feel like the way that this library happened was because we felt really inadequate in our JavaScript skills, and it seemed easier to develop a library of Purescript to handle this than it would be to learn how to properly write a large JavaScript application. So anyway, this is something that we felt was important, and it was like a big part of why we made it. This is an anecdote about how this stuff is not just what we think, but like this actually happened. There was a token sale. I don't know, Chris, what was the name of the company? Rex token sale. This was earlier this year. So ICO is like the big buzzword here. That's what token sale means. ICO. Basically, you mint a currency to do something in software. The token sale kicked off at 4 o'clock. About 20 minutes in, we realized something was awry with the contract transfer address. Whilst generating the contract bytes for deployment, a mistake was made to find the constructor parameters. Instead of a quoted string for an address, a JavaScript hex string was used. Like, I don't even know how to interpret that, because to me they're the same thing. But this quote resulted in an address in bytecode that looked very much like the actual address, but was not. And then get this other garbled string. And that address was incorrectly verified before deployment due to its similarities, which resulted in this, which is a black hole of $300 million worth, or $3 million worth of Ether in today's balance. And nothing is going on with Rex token today, probably. So now we're going to start talking a little about Purescript for people who don't really know what that means. This is taken from a recent Reddit post. Phil Freeman is the creator of the language Purescript. He's also, I don't know how he sleeps, because it seems like he does way more than anybody I've ever seen. Like he's all over the place. So This is in response to like, why is Elm more popular than Purescript, or like, why does Purescript exist if GHC.js exists? GHC.js is the GHC Haskell compiler to, it's a Haskell to JavaScript transpiler, which is like a massive piece of software that we considered in the design space for Foam, but then ultimately decided not to because while we're pretty competent and feel good about what we do, it seemed like a really heavy project to get involved with at the time. So this is Phil's answer about why Purescript. I don't know if you can read it, so I'll read it out a little bit. Somebody points out, I'm not super familiar with Purescript, but my impression is that it's trying to be a better Haskell than Haskell. The answer is that that's definitely not an explicit goal, but we did tidy up some things along the way we thought were worthwhile. Semigroup, monoid, applicative monad, foldable traversable, num versus field, and so on. I started Purescript because the language I wanted on the front end didn't exist, and that's why I still work on it and use it. I want type classes and functional dependencies and higher kind of types and rank n types and various other things in my type system. And I want predictable code generation in a minimal language and standard library. That combination just didn't exist when I started Purescript. Now, I've linked to another article that I think was maybe like a year-end summary or a state of affairs with this, which you could read. Our slides are available on our GitHub IO page, so we'll also include that in the email. But yeah, this is basically it. So some people say like, why not Elm or why not GHC.js or stuff? And it's like, well, those don't give you what Purescript gives you. So it's like, why don't you use eggs when you need flour? It's like, I need something else, thank you. But like, anyway, yeah, we were super happy with it. It was pretty hard at first because there's basically no examples of anything really complicated, like exposed. And one of the points that Foam is going to try and make is all of our stuff is going to be open source at some point. So we're hoping that we're going to serve as some sort of repository of like relatively complicated Purescript code that you could maybe find what you're looking for in there if you can't find it buried in some GitHub issues page, which is no longer open. What is Purescript really offering you as a programming language? It's sometimes called the Haskell programmer's solution to the JavaScript problem. You probably all know what the JavaScript problem is. If you don't, you should ask your neighbor. So what does this really mean? Algebraic data types, row types. Algebraic data types basically means that everything is what's called a sum of a product. It's like a very general decomposition of all data into like one of finitely many schemas. Row types are something, if you're a Haskell programmer, you probably have seen a million libraries trying to give you the advantages of that, but they use like 800 language extensions and like GHC 8.3, which isn't even out on Nightly yet. So like, anyway, this idea of like, we just kind of want like records, like JavaScript records that have key values, and I kind of want to pass that around firsthand, and I don't want to have to prefix everything with the name of the data type to avoid name collision. Like that kind of thing is what we're offering, what Purescript is offering you here. Type classes, everybody kind of probably knows what those are who does Haskell or Purescript development. Functor, monad, foldable, etc. Basically like relationships among types. They can be used in many different ways. Sometimes they're used like as interfaces, which you may have heard of in other languages. Sometimes they're used just to help solve constraint problems. So like constraint solving is like a big part of Purescript in a way that I feel like it's not in Haskell, just because of the way the constraint solver works. It's kind of like helping you describe what you're doing at the type level, and then possibly performing some unsafe raw JavaScript operation in order to make it happen, but just constraining the possibilities of what types could even enter into that validation is like a big part of it. So like there's a type level prelude library, which I would encourage you to look at because it's funny because there are no like type classes methods in that library, only type classes that kind of govern like how rows are built up over time, etc. Pure extensible effects, that may go away. Some people don't like that you annotate every effect that you have to do, and when you get lazy, you just put an underscore. Maybe IO subsumes all of that. Prisms, limbs, traversables. This is an example of some Haskell data declarations to make sure that Purescript to see that you understand what I mean by sums of products. Like my prod is like basically a tuple, right? It has like two values. You need both of them in order to make a myprod. My sum is what's called like an enum, or sometimes called like an, or no, this isn't. My sum is like a sum type, so it's like one or the other. Either it's an int or it's a string. So that's what's meant by sum. Sum of products would just be like some iteration of one over the other. my rec, this is a row type, or this is a record, which is like an instance of a row type. So what this is saying is that you have a field called name, which is this type string and of size int, or size, which is of type int. And then later, like, you can just dot access these things like you do in every other programming language, which is makes for like pretty readable, like kind of object-oriented feel for like record accessing and updating. So other benefits of the Purescript thing, which we feel like, and I've actually used this to a large extent, like the human readable JS output is like pretty sweet, actually. It can help you when you really don't know what you're doing, especially like if you know some JavaScript, you can kind of figure out what's happening. If you write really complicated Purescript, it gets pretty hard. It has extremely easy to use FFI, like foreign function interface. So if you're like using some highly optimized like KD tree or whatever for nearest neighbors, and you don't want to re-implement the thing in Purescript because it would take you a long time and it'd probably be slower anyway, you can easily just like import these things into libraries and put typings on them in a sensible way that you can use them natively. And it doesn't optimize, that's a kind of a bad point yet. There are talks of other backdoor, like Purescript is really a language specification, less of a language itself, in the sense that like there are many possible backdoors in the same way that like, whatever, you could write it. Haskell is a language specification. It has like a Java backend. It has like, somebody's writing an LLVM backend for it now. It has obviously like the C++ dump. So anyway, like who knows what the future is? Erlang is a possible future. Like at some point WebAssembly hopefully takes over. And then, JavaScript, the transpilation step probably won't even exist anymore at that point. I don't really know what the future holds, but it'd be interesting to find out. I'm going to skip this slide because we already talked about it. Let's move to the library. So the Purescript-web3 library layout. So this formatting is really terrible. The low-level serialization and RPC layer, that's like the library. So like how do you deal with solidity types? How do you deal with like encoding and decoding functions? User interface, Web3 API. So like if you have an Ethereum node, how do you talk to it? Then there's the user interface and generator tool. So probably the coolest thing about this project is this code gen tool, which I talked about, which is like really not that complicated. It's gotten a major refactoring over the weekend. And now is like, it's like a pretty lightweight code gen tool that due to the type system can leverage some like pretty awesome, I don't know, it's cool. We'll show you it later. So then there's like the contract module, which is, the way that we see it, there's only really 2 modules that if you use our library that you would ever end up using because of the CodeGen tool. So the CodeGen tool generates your client library for you. You're probably just going to use that if you're just like looking to interact with smart contracts on Ethereum. If you want to actually interact with your node in some way, you might need our actual like API client or whatever. However, the contract module, there are a few things in there which would be useful to you for like event monitoring and stuff. And we'll talk about the methods and events. In the meantime, I'm going to check in on this kitties thing, see how it's doing over here. Well, they're coming through, but it looks like we lost our images. So in the meantime, I'm only keeping 10 in memory because I don't want to crash the browser while we're talking on this presentation. But these kitties, basically this is a monitor to monitor all these like crypto kitties which are being sold on every block. I wish the SVGs were there because they're kind of cute. All right. Solidity types. We did a couple of things here that were kind of making up for some lacking features in the Purescript type system. Sizing is really important in Ethereum. Most primitive types have sizes like ints and byte strings and arrays and whatever. So it was kind of important to like not have a really bloated code base to implement some sort of type level numbers in Purescript, even if they're not native. Like GHC or like Haskell offers you type level naturals, and maybe even ints at this point. I don't even know. Purescript doesn't do that, but you can fake it pretty easily because all numbers are composed of like smaller numbers called digits, and then you just make 10 digits, 0 to 9, and then you compose them using this data operator to compose digits, and all of a sudden you have all the numbers and that at least I can think of, minus the negative ones. So for like things which kind of have a more let's say like inductive relationship, like you might need something like successor and zero, like piano numbers. So we have these as well. And then we can talk about things which has size, like in such a way that we can control that, make sure that the inputs of things have appropriate sizes. So for example, like, there's also like what kinds of sizes of byte strings exist? All the numbers from 0 up to 32, or 1 up to 32. Those are the possible sizes of byte strings that you can have in terms of byte size, which is different than int sizes. Int sizes, you can have every multiple of 8, from 8 to 256. So we can do like some pretty fine level constraining, and then to make it pretty easy on you, we don't expect that you use this successor notation everywhere. We type alias everything from like 0 to 16, which 16 is like a magic number in Ethereum, because 16 is like the size of the stack depth of their virtual machine. It's a pretty primitive virtual machine, so you can't really have tuples of size 17, because how are you going to fit them all on the stack before you like pop them out the door? So you only really need like numbers from 0 up to 16, which made this type level number problem easier to solve until somebody figures out a better solution, either in Ethereum or in Purescript. So sized ints, we have to use this like big number type because JavaScript doesn't, first of all, JavaScript doesn't even have integers. It has floats. And I think that the maximum float size is like 2 to the 52 or something really arbitrary. So big number is like our Haskell integer, it's an unbounded integer. And then we do this kind of sizing. So like this is how we do, this is how you see stuff. It's uint n is parameterized by another type in, and it's just a wrapper around big number. And this n is where we control the sizes of things. So like a known size, n results in the possibility of transferring a big number into possibly a uint of that size. Obviously, that's like a runtime failure capability there that's going to do some checking for it to make sure that the size of the thing is at most the size that you're claiming it is. And then you end up with this kind of funny notation, but you get really used to it. At least the precedence takes over so that there's no parentheses. So this is like a 256-bit integer type unsigned in our type system. So when you see stuff like that, it's like, it looks way more complicated than it actually is. Length index vectors, this is like a popular for every intro blog post in dependently typed programming in Haskell. Vector NA, so like somehow it's just a wrapper around an array, but we can give it an interface that's similar to like building up length index vectors. So here we can use this n type, which is for all of our size stuff. You got the nil vector, which is a vector of size 0. This vcons operator, which basically takes a vector of length n and turns it into a vector, n and a, and turns it into a vector of one more length. It's like lists, but you keep track of the size of the thing as you're building it up. So then we can also do this sort of dynamic conversion with possible failure by playing with some of the, this looks maybe scary if you've never seen this before, but this proxy thing is just a way to bring in the size into scope, and it allows you to do things like checking, is this thing not equal to the length of the thing that it says it is? If it's not, then fail. Otherwise, yeah, wrap that thing in a vector and it's good to go. And then you get this kind of nice syntax for like basically building up statically or dynamically, not dynamic, I don't know, let's say statically, length vectors with this sort of like cons operator always ended by the nil one. So this is a vector of length 3 of bools. Yeah?
Is it possible to define total append for these vectors?
Total append being?
Being append that takes a vector of n, returns a vector of n plus n.
Yeah, I would say that the answer is yes. So I don't know her real name, but Bodil. Yeah, so she wrote, like, I kind of ripped this off from a much more larger type level naturals package that she has, where she has those relationships of addition for sure, and other ones also. I don't remember how extensive her type level naturals package is, but through like type, maybe not just in the type signature, but with certain type classes for like sum, for example, you can get that kind of thing going. Yeah. Yeah, for sure with type, yeah, if you want to start adding some constraints here, you can for sure get that kind of behavior. So tuples, like I mentioned, tuple is kind of like the basic product type that exists in, there's no other one that exists in Ethereum. So like I said, we had to, and surprisingly there's no native tuples in Purescript, so that's why we define them here. They're defined elsewhere inductively, but it's easier just to deal with them non-inductively here. So we also defined, you'll find them in our library, even if they exist somewhere else. The first iteration of Purescript-web3, we did these tuples really like the dumbest way possible in order to get out the door. But I'm going to talk a little bit more now about how we implemented these like serialization stuff, which was kind of interesting. Basically, like everything that exists in, like when I say Solidity or Ethereum, I kind of mean the same thing. It's like there are certain types that exist, and basically you need to transfer these types to and from a byte string using a standard encoding, which is defined in the Ethereum specification for the protocol. It's pretty boring to read, and it's really difficult to get right because the documentation for this $50 billion software project is written like it was some sort of like README in some JavaScript NPM package or whatever. It's amazing. So we took the trouble of like figuring this out. In the meantime, we found a lot of bugs in the Haskell library, which are not currently fixed. So if you're using that one and you find anything, maybe they'll get fixed later. We're going to work on it. But basically, it's just like if you ever use like ASON or Argonaut or whatever, you would know how these things work. There's always an encoding type class and a decoding type class. And not everything sometimes which is encodable is like sometimes in this world anyway, sometimes which things are encodable or not decodable. So for example, like a function call, like how do you decode a function call? Like we'll go over that later. Or like an event is something which is emitted by the blockchain, so why would you ever need to encode one? Anyway, here's an example of what this kind of code looks like for our size types, which makes it kind of interesting that we can always keep this type level information around. For example, for deserialization, it's more important like this, how do you decode a uint of size n where you don't really know what n is? Like, well, you just decode a number, some 256-bit integer, and then you check see if it's at most that size. So I don't see that here for some reason, but oh no, that's just an oh yeah, uint in from big integer. Okay, so sorry, I actually placed the wrong code snippet here. Uint in from big number is really what should have been posted here, which takes into account that size n here. My apologies. We'll fix it when we email out the slides. But anyway, it's like, okay, cool. Then I can get some helpful error message about why my thing didn't parse correctly. Well, it didn't parse correctly because you gave it the wrong size, or you were expecting the wrong size. So this kind of like index for integer sizes, or integer or uinteger sizes, is pretty helpful for like debugging, but also helpful to make sure that you don't submit some data to your contract which is too big. Or yeah. Tuples, like I said, all the Solidity functions accept and return tuples, and then events are also admitted as tuples, but that's really complicated because of some decisions that were not mine. Encoding and decoding is implemented generically in our library. But this is pretty sweet because, well, generics, if you don't know what generics are like I said, every PureScript type and it's something like a sum of products. So like a product is kind of like a tuple and a sum is kind of like either you have this or you have that thing. And these compose to make all possible. And records are kind of like products with more information, right? A record is like, it's like a product that doesn't have a well-defined order, maybe. So if every data type is composed of sums of products, the idea is like, well, you should be able to define whatever you want to do on these generic structures, which are sums of products, and you should be able to. So everything should be definable on these like build-ups of sums of products. And so in order to do that, why don't we just do them on the basic types, like the most reduced things like bool, boolean, or like int. And then we have the rules for combining them, like product or sum, and so we just define kind of inductively what to do. We start with the most basic things, tell you what to do for that, then we tell you if you have a sum of basic things, what should you do for that? If you have a product of basic things, what should you do for that? And then all of a sudden you're able to like mix and match these operators in any way that you can do this serialization for any arbitrarily complicated data type. So like in PureScript, like a basic data type is wrapped in something called argument. A product of A and B is, basically just a wrapper. It's like a tuple. It's A and B. A product of A and B is literally a constructor called product. Then you give it an A. Then you give it a B. A constructor has a name. So, like, I'll give you this example down here for a second. But constructor has a name and an argument. And what is that really? It's just a wrapper around that argument that carries around some type level information about that name. Symbol is kind of like a type level string. If you don't know what it is, it's not super important. So then you can do something like this. Okay, I have tuple. I told you we made this tuples library, right? Tuples 0 up to 3, or tuples 0 up to 16. We have this tuple 3 that has a bool and a string and some 8-byte integer signed. What's the generic representation of that thing? Well, it's some constructor, namely tuple 3, which is wrapped around some other value. That value is a product of 3 things, but products have 2 things, so they're kind of nested. It's a product around a bool, and the other factor is a product around an argument of a string and an argument of a UNDA. And once you start doing generic programming, you realize you're never actually ever in life doing anything interesting. You're just basically pushing like values up and down some generic tree, and it never, like everything is always the same. And you end up doing things like at the most basic possible level, and then you apply some induction using generics that allows you to do things that are like really complicated that you don't really want to think about. That's like the whole primitive here. So like that's really good for us because the encoding stuff is like kind of complicated to get right. And it was really dumb the first time we did it. We actually defined stuff in a way that, whatever, you can read the history of the repo. But like, we did it badly, and then we use these generics, and it makes everything stupidly easy because we just like tell you what to do with a bool or a signed integer, and then we let the generics build up everything else. So you just enables this insanely like local reasoning about how correct things are. And it kind of reads like a proposition of like a mathematical, like logical proposition. And for those of the cognoscente in the room or whatever, they know already that that's what it is. But like, you can also blur your eyes and read it like one, and it turns out that you're not too far off base. So like, how do you encode something of type A generically or whatever? Well, this is where there's like a little bit of bootstrapping or whatever. If I can encode an A, and then like I want to make a generic wrapper around A that lets me play well with other generics, how do I do that? Well, it's pretty simple because you didn't really do anything to A. You just wrapped it around this argument thing. And this type class instance, I leave it to the reader or whatever to like implement, but it's pretty simple. Then you do things like generic induction, which is like if I have an A that I know how to encode, and I can generically encode a B, then I can probably generically encode a product of an argument of A and B. Because like this is what told me to do the first one, so clearly I can handle this guy here. And I'm telling you right now that I already know how to do this, but the whole thing about type classes and constraints is it's like a way of being lazy. And you say like, I don't really know how to do this right now, but I promise you somewhere else in the code base you can like figure out where this is actually defined. So like Haskell is like a lazy language because it's like lazily evaluated. But it's also lazy, this type class scheme is lazy in the sense that it's like, I don't really know what to do right now, but I told you earlier or I'm going to tell you later. So this enabled like I said, some extremely local reasoning that we can use to build up like the correctness of the encoding schemas in a way that, so the HS-web3 library, if you ever do Haskell Ethereum stuff, they use template Haskell. They're like some Russian IoT company. Like we talk to them on the internet occasionally, and we work together on their repo, but they haven't made any changes to ours. And they use template Haskell for everything, and they got a lot of stuff wrong. Their template Haskell is at a level that I have never witnessed before. It's pretty complicated. But they got things wrong, and I think that the generics thing makes it pretty easy to get it right. It also allows for an insane amount of code reuse because you can, once you have things done on generics, like you don't even care what the values are anymore. You just like ask, does this thing have some generic decomposition? And thanks to like Gershom Bazerman, I think, made the generics, or at least the first pass of it in Purescript, the answer is always yes, because the compiler generates generic instances for everything for you. So you don't even have to implement those. Like, you just get them for free, or maybe Gershom gave it to you. I don't know. So like, generic encode, the type signature here kind of tells you what it does. For any kind of A or rep, where A and rep are type variables, if A has a generic representation of type rep, and you can generically encode rep, then you can generically encode A. How do you do that? You first change A to its generic representation, and then you apply generic encode. Like it makes your code really boring, but it also makes it extremely maintainable and easy. So similarly, like our Web3 API is kind of clever. So these are basically like all of the endpoints that exist on your Ethereum node. We implemented some of them. Somebody made a PR the other day for the rest of them. I just want to show briefly like the documentation for this, or like they act as a kind of documentation, that doesn't exist in other like, it exists as a README file in a JavaScript repo, but here it's pretty nice because we get it on Pursuit. So like if you ever forget what all your ETH endpoints are, you can just check out our stuff on Pursuit. They're implemented all in a kind of funny way. I just would like to point out that like they're all implemented in exactly the same way. They all say, okay, this is not super unsafe. It's just like a thing that's here because of technicality. But whatever. If you read all of these, you realize they're all exactly the same, and that's because they uses some type stuff or whatever that I didn't think about, but it's pretty cool, and the Russian guys figured it out. And it makes it so that like it just reads the type signature and then figures out how to do all the encoding for the RPC call that you want to do. So like if we wanted to make if Ethereum came out with 1 million new endpoints tomorrow, I would just do this or like write a script that parses their like API docs and generates the stuff for us. It's pretty cool. So we have generics, which make the serialization, deserialization trivial. We have this type foo that makes this RPC stuff really trivial. So like our whole library is like pretty trivial. And it's good because, yeah. So that's what I was saying is that like, yeah, if they came out with new RPC methods tomorrow, we wouldn't spend a lot of time like constructing RPC templates or whatever. We would just like I would copy and paste whatever the other things that were there and I would edit them by hand. It's pretty nice. Let's talk about the user interface for the contract because that's like what you're going to end up needing to know. So yeah, querying. So what are we going to talk about? Like integrating with MetaMask. Probably people here don't know what MetaMask is if you've never used an Ethereum. Does anybody here know what it is? Okay. Does anybody here, were there questions? I didn't see. Okay, so MetaMask is like your key management system in your browser. I encourage all of you to install it. It's a Chrome extension at the moment. You can install it and play around with it. Basically, it allows you to manage signing your Ethereum transactions in the browser. And our stuff integrates with it because if you want to make a front-end application, you need to integrate with MetaMask. If you don't, you can't do anything. Calling contract methods, and then we'll talk about the client libraries generated from the CodeGen tool. So here's like a really stupidly simple storage contract. This is this is like the hello world of blockchain. So it's a contract which manages a single count and an event called count set. Count set obviously fires whenever somebody sets the count. If you want to set the count, all you have to do is provide me an integer, and I'll override that one without asking you any questions. So like our CodeGen tool, like somehow we need some sort of like FFI stuff in order to interact with the stuff in Purescript. So like our CodeGen tool generates, I'm not even kidding, it like literally generates this. It's even well templated. Like, and there's no template Purescript, so it has to be like in a text file. But anyway, we're not going to litter your like repo with a bunch of garbage text file generation from some CodeGen tool. We're just going to give you like the basic necessities of the things that you need. So like here you'll see like set count and count. So I said earlier that if you include this public keyword, you get like a count getter or whatever generated. That's this guy here. Set count obviously is the one coming from the function here, and this count set event is the one that's like coming from this definition of this event here. So what does count do? Okay, so these addresses are basically like the contract address and the sender address. The call mode is like, you can basically, this is a non-state changing transaction, so you can make this, you need to specify what state you're looking for when you make this call. So like, would you like to query the state as of the latest block, as of the Genesis block, as of block 247, whatever. You need to specify what you're looking for. Set count, this is a transaction. So call mode is irrelevant. You're trying to update the most recent state. And we know that the set count, in order to set a count, you need to provide a uint, which is a uint 256. So that is reflected here. It's the only argument to this function. It returns a hex string, which is the transaction hash. So that's like your reference that you need to check in later to make sure that this thing actually went through. So at that point, you could either pull the transaction hash for the value, or you could just store it in a database or whatever you want to do with it. This count set event is something which is going to be emitted and decoded by your application later. So the generator benefits, like, this is not, we went over these earlier, but I'll just read them out. Reduce the boilerplate, so like you don't have to write your own FFI for every smart contract project that you do. We're just going to generate it for you. It's really simple. You don't want to have access to these raw encoding and decoding devices when you're doing stuff because it's really error prone. Like no Ethereum library should make you do that. Like Web3.js doesn't do that. Nobody does that. So we offer you that through the generator. The generator is meant to be run as an npm build step. So that's what we were talking about earlier. If you break changes to your smart contracts, then you don't need to scour your source code, try to figure out everywhere you use the old versions of your contracts. You're just going to break them, and then you'll get warnings from the Purescript, or errors from the Purescript compiler telling you where they are. Then those errors are getting better and better. I mean, sometimes they're terrible, but like some, like they have like 8 different. It's like T8 is not matched with A17, but sometimes they're really helpful. These are helpful. And specifically, generated types allow for like higher levels of abstraction. So like, we're going to generate some types. I'm kind of lying that this is all that's generated. There's a few other things. I'll show you if you really want to know what's generated. But it's just basically some type definitions and some type class instances which are generated for you because we need that for inference in order to make things so nice. Also, another thing that we can do for you because we generate your code is that you'll notice that this function setCount is non-payable. Like, it doesn't have the keyword payable, meaning that if you try to submit a transaction to this, using this function in a way that deposited Ether to this contract, your transaction would fail as of a recent iteration of the EVM. But we're offering you that like in your contract code because this function doesn't even accept Ether. So like we can read these things out in advance, and we don't even give you the option of depositing Ether if you use the generated client library. This I'm going to skip because this is like kind of showing you like the generic, definitions of things, and I'm going to kind of like move ahead to this is like a generic. You can read this stuff in the library. Like, I encourage you to just like, yeah, you can read it. It's not that long. It's more complicated than it looks. I will show you an example of like what it looks like to monitor an event. Sorry, it's actually more. So I'm not even kidding. This looks really nice, right? Like, what am I supposed to do with this trade? This is a transaction thing. Okay, there's some weird stuff about symbol and Ether unit. I can imagine that that's some unit of Ether. And then the maybe address, that's like the address you want to send this transaction to. The maybe is because the null address in Ethereum is very special. It's like how you create contracts. Your address, the payment value, and something. And then there's like some tag, that's noise, whatever. And then A, what's A? I don't know what it is, but oh, there's something missing here from the, no, okay, there's not. There's not anything missing, it's just not, it got clipped out, like it's somewhere up higher in the file. Anyway, A is some kind of thing that method data. It's something that has an encoding schema of some type. So like, this thing works for everything. Making that work was kind of complicated. This was really complicated. This event thing, so I mentioned that like events are complicated. It's because of like how they're emitted. It's like an event is like a tuple, but for some reason when it gets emitted from the blockchain, it's emitted in like pieces. Like some of it goes over here and some of it goes over here, but then you're supposed to like magically combine everything again to make a tuple, and like so that's actually hard. I wouldn't look at that if I were you. So here's an example of what it looks like to like, how does this look in your app or whatever? So like we use Thermite and React, Purescript React at work because we have some external dependencies on some mapping software which has React bindings. So like we wouldn't want it. Plus it's easy and it's fine. Like it's great. So what does it look like to like monitor the count or whatever if you were going to monitor this event that you're looking for? It's like 4 lines of code or whatever. So this is to including the React stuff. So like, what do? You get the props or whatever. I don't even think we use the props, so that could have been excluded. Run Web3. Okay, that's running some Web3 with some MetaMask context or whatever. That explains how you're going to talk to the Ethereum node. Then what do? You use this event combinator, which is defined here. You'll notice event takes a handler. It takes whatever the event type that gets emitted and returns. And then ask you to basically decide whether to continue polling for that event or to stop. That's what's covered in this event action. And then the change context provided by the reader monad is like all the metadata that came with that transaction, like the block number and like the transaction hash, etc. Stuff that does not make it into the deserialization of the actual A itself. So then how do you like use this thing, use this event, and then you have to actually specify, the type needs to be specified here because event is so generic that if you just like, if you're not specifying the constructor that you're using that represents the data, event data, it's not going to know how to, it's not going to know what you're wanting. And so then what do? Okay, you have this event type. Now you can do anything you want, include query more Web3 data. You can like make an AJAX request. You can do whatever you want, put it in a database. It's like at this point, when you're inside of this do block, you're literally inside of AF, if you know what that means. So yeah, it's superly simple to like get these things up and running. More complicated example, we have like our foam. I'm going to refresh this because we've seen these. We have this thing, and we have our foam demo app, which we wanted to maybe, we have the hello world. So let me give you like a brief like example. So we have 4 repositories. One is called Purescript-web3. One is called Purescript-web3 generator. That's the code gen tool. We have Purescript-web3 tests, which allows you to use Truffle is like a Ethereum build tool. If you don't know what that is, it's like how you deploy and manage smart contracts. It's written in JavaScript. It works fine. It's like, it leaves a lot to be desired, but whatever. So, but you don't want to write your tests in JavaScript if your Purescript app is like, you want to write your tests in the same language that your app is written in so you can like make sure that stuff works. So Purescript tests is like an example of how to write tests in Purescript, but maybe use the Truffle build and deployment tool under the hood. And then there's Purescript-web3 example, which is like the Hello World project, which I'll just like open as an app, not as a code base. So this example, and then like, man, I'm gonna have to like deploy a contract. I don't know that you're gonna get to see this one. So, okay, so fine. Here, let's just do it. Like, we'll show you the flow. So,
Make it bigger.
yeah. So, I'm gonna set the mic down for a second because I gotta do something. Oops. Oops. So Ilya over there made this pretty cool. I don't know if you ever used, anybody who actually does Ethereum development here probably uses test RPC thing, which is like some JavaScript VM that like reads, I don't know how it works. Like
They embed the C++ Ethereum VM, and then they just really quickly, change logs or set the environment to whatever you want.
yeah, so like I didn't like it, and it was hard to use because it doesn't match the like. It doesn't. It's like running a different VM than your Geth node is. So like, why would you test your contracts on something which is like a mimic of the production environment if you could just have the production environment for free? So Ilya made this cool Docker image called Clickbait. That's like a really fast Geth configured Geth node, so we can just run Geth stuff. We can run our code against like a real node that's like deployed in the wild or whatever. And then if I can just do the deploy here, we'll get a contract address running. So this is like, running a blockchain. I'm like the only one on it. But if you want to get on it later, I'll give me your address and I'll send you an invite. I'm pretty ether rich on this one. So simple storage is being deployed. Simple storage just got deployed. So now I can copy this thing. This is the address that contract resides on in this network. So then I just have to do this. Whoops. I'm going to blow it up in a second. Just wait. So right now I'm just like running the, I'm running the app. Whoops. What is that saying? Oh, right, the Kitty app. It's running on the same, we use the same Webpack configuration for everything. So I'll just close that. Yeah, hang on. What happened to that? Oh. I think that the node env is localhost. Actually, it's even better. It's MetaMask. MetaMask is the most frustrating variable in all of this because I'll show you what it looks like. It's this thing, this fox that sits up here in the corner, and I can change it to any of the popular test networks for Ethereum development, or I can change it to localhost. And a lot of times we don't remember where our app is deployed. Is it on Ropstein? Is it on Rinkeby? I don't know. Just try all of them and see where it is. So I am extremely annoyed. I've never gotten that right. So this is my ether balance on clickbait. It's pretty big. I'll copy and paste it because it's so big it can't even fit into the thing. That's my ether balance. So this makes it so that you don't have to if you work with Rinkeby or Ropstein, you have to always ask for more ether because they don't just give ether away for free on those networks. They do give it away for free, sorry. But they don't give away as much as you want because then you could just spam the network all the time, just with noise. So they make some kind of proof of work type entry. Localhost 8080. So okay, the current count is 0. That makes sense because I just deployed the thing. And this address, it's already talking to my MetaMask thing to figure out that my address is 278 something. That's what that is. And then I put an account here. I'd like to submit that. MetaMask picks up already that I wanted to submit a transaction, so I can submit it. And then I kind of just sit here and wait, possibly forever, because I think something is wrong from earlier. Because it looks like some dots are pending here. You know what? That might just be me. That might be my MetaMask. So anyway, so this is the best part. We can just switch to a different network and do the same thing in a different network. But it's not super important even if this works, because what's more important is that we know that it does work. Here we go. This transaction was 9 hours and 36 minutes ago. This is Etherscan, by the way. This is how you figure out this is how you figure out what's going on in the blockchain. So I know earlier that the last transaction I submitted was when I was playing around making sure this thing worked for today. So I'm just going to restart this is the weird thing. It's we have our, whoops. Yeah, look at that. It's already it remembers 7399. So my fish shell is working. So this is the best thing about Ethereum is that we just deploy, or the RSEP, we just deploy it everywhere, and then I always have a copy of it somewhere. And now I'm gonna restart the app with looking at a different smart contract, the same smart contract deployed on a different network, and my app still works or whatever. And this is the sort of weird thing about it too, is that if somebody the Kitten people came out with this killer app that's making millions of dollars for trading, Tamagotchis or whatever on the internet, and you could then make your own front end for that app, and they can't stop you because it's all publicly deployed. So if you think that you can make a better app for my company than I can, all of our code and stuff is out there. All you have to do is just make the front end for it. So yeah, okay, so this is the count thing going up here. Let's do this. I'll just submit this transaction. Submit that. Then we're going to wait for an hour while the blockchain happens, because again, it's the slowest computer that I've ever encountered. And hopefully this number here will be 321 or whatever I put in, whenever this ... changes into this QR code thing or whatever this is. But that's pretty much it for the talk in terms of just exposure to who we are, or what is this library and how does it sit in the position of a statically typed functional programming. All right, so that didn't work on the live update for some reason, but if I update it again, there it is, 321. So at least maybe the event thing isn't, I don't know what's wrong with my browser, but in theory, this would work on a good day. Anyway, at least the number changed, right? So now if I go to Etherscan or whatever, and I look at this contract, I can see that I just submitted a transaction 23 seconds ago, and what was that data? Well, it was method ID, that's that selector I was talking about. And then here's like the 256-bit padded integer. 141 is apparently the hex string for 321. So yeah, it's all like integrated and ready to go with the existing tools, like this Etherscan or whatever is mostly for free from how we interact with MetaMask. But yeah, like we're using it in production. I don't have time to demo that, so I won't. But it'll be released pretty soon anyway, so you'll be able to see that. As far as we're concerned, this thing is production ready. There's going to be some features that we're going to implement, but people are also welcome to we accept PRs. We will help you figure out how to use it. If you need help, we will help you figure out the weird Purescript things if you need help with that. We just want people to use it because we spent 3 months making it. So anyway, that's where I'm going to stop, I guess.
I'm interested in knowing more about foam, what you guys are doing there. If you don't know.
Yeah, so foam is we offer geolocation services on the blockchain. Chris could probably tell you more succinctly, but my interpretation of the company I work for is that we offer geolocation services on the blockchain. Proof of location is what we're most interested in our first iteration, which is slightly more complicated than you would think it would be, because you're well, there's this thing called GPS, and I've got it in everything, and why don't you just use that? And it turns out that that doesn't play super well with the way that Ethereum is structured. A lot of the stuff is internal to Ethereum, so there's no notion of the outside world really. It can't query a GPS satellite on its own to figure out something about you. It's basically if you're talking about using GPS, you're talking about, well, I'm just going to upload some data to the blockchain, and God knows if it's true or whatever, or spoofed or whatever. So the idea is that you can maybe do a little bit better in the context of Ethereum with something more distributed, something more, let's say, fault tolerant, and something a little bit more secure than GPS. There's a token model to sort of back that up from an economical point of view, and then there's a lot of sort of location. It's wireless sensory network protocols that we're working on implementing in Ethereum. So. Yeah, so I'll just show the demo app is demo. Can somebody tell me?
If you don't know the VPN.
Yeah. So it's visually stunning. I mean, we're still in development mode, so we don't have one that's outside of a VPN. But it looks like it's going to bring up here. Maybe.
No. It probably is.
It seems like it's going to find it at least. There we go. So what you're looking at is is there data in this one? Yeah. So here's what you're kind of looking at. This is all written in Purescript, by the way. So let's. These blue dots you're looking at are beacons. They represent some location-aware and location-providing service that can be captured. That can be used to capture your own desire to be located. These triangles, in some way, they're polygons that represent sort of zone anchors. It's some technical wireless sensory term. We're able to do some pretty cool stuff with this is all MapGL and DeckGL, which is a layering system on top of MapGL for doing cool data visualization stuff. We have some pretty cool stuff. Ben in the back there, he's maybe you can talk to him later about how he did all this really cool stuff with these Uber data sets. Maybe you can see this. There's red lines, lasers coming out of these beacons that are kind of locating cars as they drive by. And so all of these things that you're seeing are generating transactions that then get sent out of the blockchain. We have some. This is kind of somewhere between a video game, a simulation, and a white paper, which explains technically what it is that we do. And it's these entities are basically communicating with each other. The technical phrase for how they're doing it is via something called a state channel, which is a cheaper way to do bigger amounts of data transactions on the blockchain. And then there's all of this is sort of like geared towards I guess like it was kind of an experiment in like we wanted to do it in Purescript, but we also have some pretty rigorous technical requirements from the Ethereum point of view. So like this in no small way factored into like how the library developed and like how its main use case is right now, because I think we're the only ones using it. So yeah, this is like more or less what we're interested in. I'll leave that up there.
Anybody else? Question?
I just have a question. So,
this is come out as a different question that earlier in the presentation you were talking about the touring completeness of the contracts and looking into the frames. Isn't that a major problem? I understand that if you follow what's happening with the Hyperledger projects, like digital asset, they're working actually with the specifically Haskell-based non-touring system to prevent the possibility of blowing up. Is there a possibility that anybody got a transaction that contract needs to blow up?
Yeah, so there's no token in Hyperledger or digital assets, so there's no economic component. The economic component in Ethereum is Ether, which sort of limits your ability to interact with the network. So there's this thing called gas. Gas is like so you need Ether to pay for transactions, to pay for computation. But like it's not like it's pegged like adding two numbers costs 1 Ether, because the price of Ether changes that affects your ability to do stuff. So there's an intermediary, there's a translation layer called gas. So you pay for gas, and gas is used to run computation. So like if you want to go into an infinite loop, you're free to do that as long as you have money to do that, and that will drain, and then you'll be out of money, and then you're spamming a tag as always. Yeah. There are also gas limits for like the blocks or whatever, so like it's impossible to like go into an infinite loop. Even without that, like the worst that could happen is you could expend all of the gas allowed for in the block with your transaction, then you would be sent a bill payable immediately for like $20 million or something. So like the economic model there is what backs that up.
I have another question.
Yeah.
So you very lightly touched on, you made a choice between Purescript and GHCJS. Can you add a little bit more color to that?
Yeah, or Christopher is probably better suited to that because he made the comparison matrix.
Well, I can just, that was at an early stage of the project, and React was basically a necessary condition for us to build this. And there are some ways you can do React applications using GHCJS, and we would be able to build sort of an equivalent stack using HS-web3, which would probably have saved us a bit of work, but it would have been, in the long run, more. My assumption is that it would be harder to sort of maintain the and sort of experiment using GHCJS and React, and because the applications are sort of like, you might want to be able to go mobile. I don't really know. There's certainly like a lot of room for experimentation on the Purescript side. So that was somewhat arbitrary, but leaned towards that. Then I think, in retrospect, we're pretty happy with Purescript. It turns out that a lot of things are actually a lot simpler than using Haskell. Even though there might be like an initial threshold you have to come over. Once you're there, things are nice. And sometimes just things just like compile times is not that long. So it's nice to develop.
Yeah, I would just like to add also that the original, like, I was agnostic because I wasn't really thinking about the same kind of problems that when Christopher was there. But then, like, Purescript is really small now in terms of the people that use it. But in some ways, we're like feeling pretty positive that it's around to stay. Like the core development team is like pretty on top of it. There's releases of the core contrib libraries that come out pretty regularly, and we're super happy with like the responsiveness of people. Also, like if you post like on GitHub something that's broken, even if you have dumb questions, like Phil Freeman himself will answer it 45 minutes later. So yeah, we felt like it was a pretty good community.
Yeah, he's yeah.
Yeah.
I'm wondering, with regards to either Web3 or any of the cache algorithms and things that you're working with in foam, are you considering any work to formally verify them or use any full methods? Now that you have that ability in Purescript, that people would sort of be, I guess, claiming they maybe can, but probably can't.
Yeah, so the kind of the problem that I was explaining earlier was that you can do that to not the full extent, right? Because you ultimately have released your source code on a publicly available computer. So what we can do, at least, is guarantee that if you use our app, or really if you use the library, that your contract will be used according to your intended desire when you did things like specify the function signatures and return values and things like that. So we can't really control what you do, what the functions, we don't really know what happens once you send off this transaction and it's going to be executed on this other machine. We can't help you there. All we can do is really help you make sure that your application behaves as you would expect as the application developer once you're writing front-end or back-end software. But that being said, we also look at this K-framework as probably the best shot that we have currently with the current tools available. There's a lot of stuff that's planned in the future that's pretty heady, but there's nothing available now except for the K-framework stuff that we're aware of. There's a pretty extensive tutorial wiki of K-framework where you can build a dependently typed lambda calculus in K-framework, which is more than we need. But our intended goal is to verify our own smart contracts with K-framework and to work with people who operate at that level. We're not interested in talking to people who are hobbyists security analysis, which the space is really full of. We're interested in that level, yeah.
Did you have any disappointments with Purescript or something you wish it had that it didn't? Barriers, that sort of thing?
No. Short answer to that question is not really. I mean, you could argue, there's people who complain about things of the advanced type features that are available in Haskell that are not in Purescript. And our experience is that that stuff is not super necessary for what we're doing. I don't know. We don't need anything else. We've never run into a theoretical barrier where if we only had type families plus flexible instances minus whatever, we'd be we don't have that problem. So in some ways, I think that also Purescript is changing, and it's as the language evolves, we have to change the stuff that we do with it. So the 12.0 release that comes out soon, I think, is an intended pretty big upgrade. And things that we are running into some problems now with with some bugs, and it's a pre-1.0 language. So there's some bugs that we think are in the compiler. We get some overlapping instances warnings for stuff we know that doesn't apply for, but we just ignore them because it always chooses the right one. And we know, I mean, it tells you which one it's choosing. So we're monitoring the situation, so to speak. But we know that that's an error. So those things are still, yeah, there's some weird bugs. But in terms of feature lists, no, it's great.
Is any of your front-end stuff open source or are you planning on it? Because I'm not aware of any other large production thermite apps that are really out there reference points for thermite.
Yeah, so that's the goal. That's one of the those things even before how we, our smart contract development is sort of maybe the last thing that we would expect to be released. This is probably one of the first things that we would expect to be released. The problem is that it also depends on a REST API. So you don't really want to, the blockchain is not a super convenient tool for accessing data in interesting ways. So it's not a Postgres database, it's not a NoSQL database, it's literally a key value store where somebody implemented some pretty appropriate tree structure that keeps track of all of your data. So it has extremely terrible performance for like querying, which means that you basically have to like listen to the product. Basically, what you have to do is listen for events that get fired. That you when you design smart contracts, you fire events, then you lock those in some sort of other auxiliary data store, and you query those auxiliary data stores for performance. And your really core components are what really touch the blockchain in real time. So like. That being said, like this could be released, but it wouldn't be runnable without the backend, which is a servant, which is two more components. It has a few components, but one is a servant REST API, and the other is a data processing unit, and also both written in Haskell. All of them are fully intended to be open sourced. The target timeline for that is probably like January to February. And the expectation is that you should be able to run like our Docker images for your to just run the backend because you're not maybe super interested in that as a Purescript developer per se, and you should be able to like run those Docker images and then be able to explore the app as a Purescript app with those. The timeline again is something like January, February.
Quick follow-up on that, since you serve on the backend. Are you using Purescript-Bridge to generate your types? And if so, how do you like it?
Yeah, we use Purescript-Bridge to generate the types, and we use Servant Purescript to generate the boilerplate like HTTP requests. No complaints there. It does provide it's somewhat awkward. Okay, so for the Servant Purescript, that part is great. We haven't had any problem with that. The Servant Purescript stuff is a little bit awkward because sometimes it's not clear like where those data types really belong, like because they're communicated back and forth. So like, do we use the ones natively defined in Haskell or not? It's sometimes an awkward question, but like we haven't had any real problems with it. There's some duplication, so there's some like types that are duplicated across the front end and back end, and there's some translation that happens there, but not a lot.
First of all, I really enjoyed your talk. I had two questions about Purescript. Did you, like, what was your onboarding service? Did you have any, like, just JavaScript developers onboard to Purescript? And number two was performance. Since it's doesn't have optimizations, have you run into any performance problems?
Yeah, so for the first one, we don't have any just JavaScript developers. So, like, we have maybe 5 or 6 developers, and maybe like 5, and they're all Haskell developers, like by profession, and really competent JavaScript developers, especially Ben and Anna. They're really good at JavaScript. They're good at everything, but like they're also good at that. And part of the problem originally was that we didn't have them. We just had me and Chris, and we're both neither one of us would really want to maintain a large product like that. So we wrote the Purescript library and just decided to go with that because it seemed easier than like building a massive JavaScript application that would ultimately fail. Then for the second part, like the onboarding, so the onboarding problem was not even there. But sorry, you have to remind me for the second part. The performance. Yeah, so the performance is like, we don't have a problem with it that we haven't overcome. There have been problems that like Ben has recently worked on. You could ask him like what he ran into. He's the one sitting in the back there. And so like, we're dealing with a lot of like data points here, and this visualization layers can be kind of heavy. Even though they're not written in Purescript, they're still like resource intensive to run in the browser. Certain things like the Kitty app earlier today in its first iteration was using Thermite, which uses like a list structure, like a cons list, and that is not stack safe or memory safe. It's like pretty, whatever. I've hit some problems with that. We've hit some minor snags, but like nothing serious. And also like the size of the app is pretty small. So right now it's like bigger than 1 megabyte because this app. Is bigger than 1 megabyte because we're depending on Web3.js for one function. And they recently refactored Web3.js to like be multiple submodules, each of which do one simple thing. And we're just using it for their like transport layer. So like how to reach out to a node there's a certain class there that handles that. And then once that disappears, we'll be looking at like in kilobytes again. So yeah.
All right, awesome, thank you.